So, you're watching this video right now on a screen, probably on your phone, maybe a laptop, and the data that makes up this video traveled from a server through a whole bunch of infrastructure, all the way to you. For decades, that journey has been powered by electronics. But what if I told you the future of pretty much all technology isn't about electrons anymore? It's about photons. It's about using light itself to compute, to communicate, to sense the world around us. That's the core idea behind photonics. It's about replacing traditional electronics with light for faster, more efficient, and often much smaller systems. And when you talk about the cutting edge of this field, especially integrated photonics, that's putting entire optical systems onto a tiny chip. One country consistently comes up, the Netherlands. They've built this incredible ecosystem, a kind of photonics valley that's pushing the boundaries of what's possible. It's not just theory, it's happening right now, and it's quietly starting to change everything. So, I figured it was time to take a closer look at where this tech is actually making a difference. In this video, we're going to break down 8 key applications that are all figured out. We'll look at how it's revolutionizing everything. This isn't something. This is the next major wave of technology. It's worth paying attention to. Let's get into it. Alright, so first up, data and telecommunications. This is probably the most immediate and massive impact of photonics. Think about data centers. These are the hearts of the internet, massive warehouses filled with servers, and they consume an insane amount of energy, a lot of which is just lost as heat from electrons moving through copper. Photonic chips change the game entirely. Instead of pushing electrons, they guide light. This means data can move at, the speed of light, with way less energy consumption and generating far less heat. It's a fundamental upgrade to the internet's plumbing. And it's not just in the data center. This technology is what makes things like 5G and eventually 6G actually work at scale. You need that massive bandwidth and low latency. Dutch companies are deep in this space. You have Effect Photonics, which makes these incredibly efficient optical transceivers that are basically the translators between the fiber optic world and the electronic world. Then there's Astra Bay Networks, focusing on making the connections inside data centers completely optical, which could slash energy use. It's a huge deal for making our increasingly connected world sustainable. Next up, let's talk about healthcare. This is where photonics goes from being incredibly fast to incredibly precise. We're talking about medical devices that can diagnose diseases from a single drop of blood, or even just by analyzing your breath. Because light can be controlled so precisely, you can build sensors that are sensitive enough to detect individual biomarkers. This means diagnostics become less invasive, much faster, and can happen right in the doctor's office instead of needing a big lab. It's about getting the right information to doctors sooner. A great example of this is Amazec Photonics, another Dutch innovator. They're developing chips that can monitor vital signs like your heart rate and blood pressure just by measuring subtle changes in your skin using light with no physical contact needed. Imagine that built into a hospital bed or even a car seat. Beyond diagnostics, you have advanced imaging techniques that give surgeons a clearer view than ever before, and laser surgery that can make incisions with cellular level precision. It's a quieter revolution than the data one, but for our health, it's just as profound. Okay, this one might feel a little more out there, but it's happening: quantum computing. For years, the big challenge with quantum computers has been keeping the qubits, the basic units of quantum information, stable. Many approaches require supercooling them to near absolute zero, which is complex and expensive. But there's another way, using photons as your qubits. Photonic quantum computing can, in many cases, operate at room temperature. This drastically lowers the barrier to building and scaling these incredibly powerful machines. And again, you look at the major players, and you find a Dutch company right at the front. Quix Quantum is a leader in building photonic quantum processors. They've essentially created a programmable chip for light, allowing researchers to run quantum algorithms that could one day solve problems that are impossible for even the biggest supercomputers today. This has huge implications for things like drug discovery and materials science. And it's not just computing. Using photons for quantum communication could lead to a truly unhackable internet, which is a whole other level of security. So we've talked about massive data and microscopic health, but photonics is also changing how we sense the big picture, our environment and our industries. Photonic sensors are a huge leap forward from traditional electronic ones. They can be incredibly sensitive, immune to electromagnetic interference, which is honestly a big problem in industrial settings, and can operate in harsh environments where electronics would fail. Just imagine monitoring the structural integrity of a bridge or an airplane wing in real time by embedding fiber optic sensors in the material itself. These sensors can detect tiny changes in temperature, pressure, or strain with unbelievable accuracy. Photonics International is a company that builds these kinds of custom photonic integrated circuits for sensing. Their tech is used in everything from agricultural sensors that tell farmers the exact moment to water their crops, to environmental monitoring systems that can detect pollutants in the air or water at parts per billion levels. It's really about getting much more granular, reliable data about the world around us, which lets us manage it much more efficiently and safely. When you think about clean energy, you probably think of solar panels and wind turbines. Photonics plays a huge role here, especially in solar. The efficiency of solar cells is all about how well they can capture photons from the sun and convert them into electrons. Advanced photonic designs like nanostructures on the surface of the panel can trap more light and reduce reflection, squeezing more power out of every sunbeam. It's all about making solar energy more efficient and therefore more cost-effective. But it actually goes beyond just generation. Think about lighting. The switch to LED lighting was a photonic revolution in itself, drastically cutting energy consumption. The next step is even smarter, more efficient lighting systems. And in manufacturing, high-power lasers, a core photonic technology, are used for precision welding and cutting, which uses less energy and creates less waste than traditional methods. Research institutions in the Netherlands, like TNO, are heavily invested in using photonics to improve solar cell efficiency and develop sustainable manufacturing processes. It's a key enabling technology for the whole green transition. Let's bring it back to something you see on the roads: cars. The push towards autonomous driving is completely dependent on sensors, and one of the most important sensors is LiDAR, which stands for light detection and ranging. It works by sending out pulses of laser light and measuring how they bounce back to create a real-time three-dimensional map of the world. It's what allows a self-driving car to see other cars, pedestrians, and obstacles with high precision. Improving LiDAR, making it smaller, cheaper, and more reliable, is a huge focus. This is where integrated photonics comes in. Instead of bulky mechanical spinning LiDAR units, companies are developing solid-state LiDAR on a chip. This makes them tiny, robust, and cheap enough to put all over a vehicle. Dutch company Superlight Photonics is working on this, developing key technologies for next-generation LiDAR systems. Beyond just LiDAR, photonics is also being used for in-vehicle networking. Using optical fiber instead of copper wiring to connect all the car's computers is lighter, faster, and immune to interference, which is critical for safety in a car with dozens of electronic systems. In the world of defense and security, having an information advantage is everything. Photonics is providing that advantage in several key ways. First, in imaging and surveillance, photonic sensors can see in wavelengths beyond what the human eye can, like infrared and thermal, allowing for clear vision in complete darkness or through smoke and fog. This isn't just about better night vision goggles. It's about highly sensitive cameras on drones and satellites that can gather critical intelligence from miles away with incredible clarity. Then there's the security of communications. We talked about quantum communication, but even standard photonic communication over fiber optics is inherently more secure than radio waves, which can be easily intercepted. It's much harder to tap a fiber optic cable without being detected. And of course, there's the more direct application, high-energy lasers. These are being developed as defensive systems that can track and disable incoming threats like drones or missiles at the speed of light. It's a field where the speed, precision, and security of light-based technologies offer a clear strategic edge. Finally, let's look at how we build things. From the phone in your hand to the plane you fly in, modern manufacturing is all about precision. Photonics, particularly through lasers and spectroscopy, is enabling a new level of control. High-precision lasers can cut, etch, and weld materials on a microscopic scale, making it possible to create the complex, miniaturized components needed for all the other tech we've talked about. This is how you get the intricate circuits on a photonic chip itself. Spectroscopy is the other side of this. It's a technique that uses light to analyze the chemical composition of a material. In a factory, this means you can have a sensor that constantly monitors the quality of a product on the assembly line in real time, ensuring everything is perfect. This is crucial for developing new, advanced materials with specific properties, whether it's for stronger and lighter composites for aerospace or more efficient semiconductors. Photonics gives us the tools to not only manipulate matter with incredible precision, but also to understand it at a fundamental level. So, after looking at all these different fields, what's the big takeaway here? It's that photonics isn't just one new product, it's a foundational shift in technology. It's about harnessing the fundamental properties of light to do things better. That means incredible speed for our data, lower energy consumption for a more sustainable planet, extreme miniaturization that puts supercomputers on a chip, and a natural resistance to interference that makes our systems more robust and secure. It's a platform technology that elevates everything else, and it's genuinely impressive to see the role the Dutch photonics industry is playing in this global transformation. Through a focused ecosystem of startups, established companies, and world-class research institutions, they've become a global hub for integrated photonics. Their work isn't just a point of national pride, it's having a tangible impact on the future of technology worldwide, powering the innovations we've talked about today. This is a perfect example of how strategic investment in deep tech can create a massive ripple effect across countless industries. The applications we've covered are really just the beginning. As the technology matures and the costs continue to come down, we're going to see photonic solutions pop up in places we haven't even thought of yet. It's a super exciting space to watch. So keep an eye out, because the next big leap forward in the tech you use every day might just be powered by light. Thanks for watching.